Okay, let's continue on in chapter 14, our graphing chapter. Our targets for today, I can graph sine, cosine, and tangent functions in the coordinate plane with or by hand and with the graphing calculator. And I can see the effects of the graph when various transformations are applied. So this is, yesterday we learned sine, cosine, and tangent. Period is 2 pi over the absolute value of b. The amplitude is the absolute value of a. The period for tangent is pi over absolute value of b. Vertical asymptotes for pi over 2b and negative pi over 2b. Halfway points pi over 4b a and negative pi over 4b negative a. Okay, today we're going to add the h and k element into our equations. We had a and b yesterday. Now we're going to talk about h and k. And it doesn't matter whether it's a sine, cosine, or tangent. H and k are, quote-unquote, the new center of our graph. They're your horizontal and vertical shift, just like they've been way back since chapter 4 in quadratics. When we wrote in vertex form, that was how we were shifting left, right, up, or down. That's where the vertex moved. This is now h and k are what you would call the center of your translation. So HK is like the center, if you will, of our graph and move it around the plane. H is your horizontal shift. Remember, it's the opposite of x minus h, right? So x minus h is equal to 0. It's the 0, if you will. X minus h equals 0. What makes that equal 0? That's what. That's why it's the opposite. So that's our horizontal shift. So if you see x minus a number, that's a shift right. X plus a number, that's a shift left. K is your vertical shift. It is what it is. That's up or down. K is also called the midline. I mentioned midline yesterday. Midline, if we have any old sine or cosine graph oscillating through there, it's not really implied. It doesn't apply to tangents. Necessarily, I guess it does apply to tangents. It does have a midline. The midline, that's a line that kind of divides it in the middle. It's what the amplitude can be measured from. So this is called, the midline. The midline. Okay. Let's use it. Okay, so example, let's do 3 times the sine of 2x plus 1. So what is h and what is k? That's the first thing I start identifying. Yesterday we didn't bother, we learned the basics. Now every time you graph, identify what h and what k is. I don't see any parentheses. Remember, the general form is y equals a times the sine of x minus h plus k. I don't see anything in parentheses. That tells me that my h value is 0. K, there's a number being added outside of the sign, outside of the parentheses. That's 1. So my midline, or my hk, the center of my graph, is 0, 1. That means my graph has not been moved left or right, but it has been moved up 1. So our midline, instead of being the x-axis this time, our middle of the graph is going to bounce back and forth around the line y equals 1. Our amplitude, we can still find that. That's the absolute value of a, which in this case is the absolute value of 3, or just 3. So we're going to go 3 above and 3 below the midline. So 1, 2, 3, we're going to go as high as 4, 1, 2, 3, and as low as negative 2. 0, 1, negative 2. So that's going to be how we're going to stretch. Our period is still 2 pi over the absolute value of b. B in this case is what's between sine and x. 2 is between sine and x, whether there's parentheses there or not. So it's 2 pi over 2. The absolute value, which is just going to be pi. So that's our period. It's going to repeat every pi units. So how are we going to graph it? Well, first we have to, just like we did yesterday, we have to set up our intervals. Remember, our intervals are set up by period divided by 4. Our period is pi, so pi over 4 is going to be our intervals. We start our graph. There's a new thing. Start your table at h. In this case, h equals 0. We're always going to start our table at h from now on. So, x and y. If our h is 0, we're going to start at 0. That's easy place to start, but it's not always going to be 0. If we slide left or right, h is going to change. So we're going to start at 0. We're going to add pi over 4. 0 plus pi over 4 is pi over 4. Pi over 4 plus pi over 4 is 2 pi over 4, or pi over 2. 2 pi over 4 plus pi over 4, that's 3 pi over 4. And pi over 4 plus pi over 4, or pi over 4 plus 3 pi over 4, that's 4 pi over 4, or just pi. So we're just adding pi over and over and over again. You can do this in your calculator as well. Instead of having pi on your interval, you know that pi over 4 is you're going to add every time. So we're going to use 1 instead. So 0 plus alpha y equals 1/4. So 1 pi over 4. We add another 1/4 because that's our interval. And we get 1/2 plus another, once we get it in there one time, let's go from keep repeating, 3 pi over 4 and plus another 1 pi, oops, delete, plus another pi over 4, and we get 1. So if we just add pi to those, we get the same number. So that's how you can use your calculator to find your interval values, especially when you start out at a different place than 0. It's a little easier on you. Okay, so we're going to use our calculator to graph this. Let's go to y equals. Let's clear that out. Let's put in 3 times the sine of 2 times x plus 1 outside the parentheses. Our window, well, we want it to start at 0. We want it to go up to pi, and we want to go by an interval of pi over 4. We know it's going to go as high as 4 and as low as -2. So -5 to +5 will fit our picture. And here is our graph. And notice it does appear to be raised up a little bit higher than our other graphs were. They were on the x-axis. We want to get a table. Second table. Well, it's not set up really the way we want it. We might have lucked out here. It looks like it might work out. But you want to go to second table set. We want to start our table at 0 because that's the first value in our table. Our intervals, our change in table, is second pi divided by 4. So now when I go to my table, it's going to start me at 0, and it's going to give me all the outputs I need. 0 output is 1, pi over 4, which if you do your calculator is 0.7854 as a decimal, up to 4, back down to 1, down to -2, back up to 1. And the process would keep repeating if we wanted to. Now we take this and we graph it by hand. Pull one of our tables up here since it's spaced together. I'll pull this one up. And we know our intervals, we go by pi over 4. This one looks like the intervals under a pi over 2, so we just go halfway in between those points. So 0, 1, not 0, 0, I almost said that. Pi over 4 would be halfway between pi over 2 and 0, so pi over 2 up to 4. And then we go back to pi over 2 down to 1. 3 pi over 4 down to -2. And pi up to +1 again. And we just connect our dots. We know it's a smooth curve. Here's one interval graph. I'd say it compares pretty favorably to this. We just have a slightly different window as far as our x's are concerned. It's usually more stretched out. We can see on our graph it goes up to 4 as low as -2 at the points that we do. So I'd say that is a successful graphing of this sine function. Okay, real quick, I just want to show you how you can do a tangent function as well. I already have the information up there, so just kind of copy and follow along. H and K influence my tangent functions as well. The center of that translation is going to be HK. In this case, if you look at this, there is no K value, but there is an H. The H is the opposite of what makes x plus pi equal 0. That's negative pi. So we're shifting left pi units. Our period is still 2 pi over b, which is 1. It's 1x. So our period is, excuse me, not 2 pi over b. Our period for this is pi over b. So it should just be pi. So pi over b or just pi. Both sides sine. So our vertical asymptotes. Now, vertical asymptotes, that's what we're going to, the h is going to influence that. So instead of just pi over 2b, notice here it's pi over 2b plus h and negative pi over 2b plus h. Our halfway points are influenced by both h and k because they have a y coordinate now. So it's negative pi or pi over 4b plus h, a plus k, because k is our vertical translation, negative pi over 4b plus h, negative a plus k. So we plug it in, we simplify pi over 2 times b, or pi over 2 times 1, plus our translation was negative pi, so plus a negative pi. We make that, we simplify that, we get negative pi over 2. Over here, we do the same thing with the other one. The opposite of pi over 2 plus negative pi is negative 3 pi over 2. On my graph, you can see I put the asymptote lines there. Also, halfway points, pi over 4 times 1 plus a negative pi, comma, our a is 2, so 2 plus 0, we don't go up, so that simplifies to negative 3 pi over 4, 2. Over here, we're going to spit out the same thing. We'll cover that. Negative pi, 5 pi over 4, and negative 2. Those are our halfway points. I plotted those points on both sides. Hard to see, but I did. Right here. 5 pi over 4, negative 3 pi over 4, negative 2 right here. So that's how you can graph these translations on the tangent function as well. Okay, normally if we were in class we'd have done more examples, but you have a basic foundation now. Tomorrow in class we will do 20 examples together. Bring your notes and I'll see you then.